You know, in the world of healthcare, some of the biggest, most important decisions are often made in this thick fog of really complex data. But what if you could just flip a switch and turn on a light? Well, today we're going to look at how artificial intelligence is doing exactly that, turning that fog into a crystal clear forecast. So just think about that for a second. How do you make a billion-dollar healthcare decision? And I mean, this isn't some hypothetical question, right? This is the reality for leaders in the pharmaceutical world every single day. The answer they come up with determines which life-saving drugs get made, where they go, and who they ultimately help. The stakes, they couldn't be any higher.
And the journey to that billion-dollar answer always starts right here, inside this fog. It's this swirling mess of research papers, patient data, market trends, clinical reports, you name it. And navigating this successfully, well, that's the difference between a breakthrough therapy that changes lives and a really, really costly dead end.
So let's break it down. What exactly is this high-stakes fog made of? It really gets to the heart of the challenge for any modern pharmaceutical strategy.
I mean, think about it. Every single one of these critical tasks relies on understanding the landscape of a disease. How many people actually have it? Where in the world are they? Is that number growing? Answering these questions has always been this slow, painstaking, manual process. And if you get it wrong, we're talking billions of dollars and years of research potentially going down the drain. So, how on earth do you find your way through that fog? Well, you need a new kind of compass. And that's where this new category of tool comes in. It's called Epidemiology Intelligence. And yeah, it's all powered by AI.
Okay, so what does that actually mean in plain English? It's not just about throwing more data at the problem. No, it's about taking really high-quality data, stuff that human experts have already vetted, and then letting AI supercharge it. The AI can connect the dots between hundreds of different studies in a matter of seconds, spotting these subtle patterns a human analyst might just miss. For example, it could find a hidden link between an environmental factor in one city and a rising number of cases of a rare disease, an insight that might take a whole research team months to uncover. That's how it can create these forecasts with incredible speed and, more importantly, accuracy.
So this whole approach really stands on three main pillars. First, there's the AI-powered synthesis, which just means the platform can instantly connect the dots across tons of reports. Second, it thinks globally, looking across many different diseases and countries at once. And third, it's transparent. It delivers the kind of intelligence you can actually bet a billion-dollar decision on.
All right, that all sounds great in theory, but how does it actually work? Let's walk through it. How do you go from this huge, messy fog of data to a specific, actionable answer? It actually follows this really neat, logical path. A strategist starts big, right? They pick a disease they're interested in. Then, the AI helps them drill down, slicing up that population by things like how severe the disease is or when they were diagnosed. From there, they can compare what's happening in different countries and, this is the crucial part, pinpoint exactly where the biggest unmet patient needs really are.
Let's make this real. Imagine you're at a pharma company, and you're developing a new drug for a nasty, persistent cough that comes with a serious lung disease called IPF. You absolutely need to know the size of your potential market. So you can ask the platform this exact question.
And boom, just like that, in seconds, you get a crystal clear, data-backed answer. The forecast for 2026 instantly shows that the US is the biggest potential market by a long shot, with over 82,000 cases. But you can also see significant patient populations in Japan and the UK. Now, this isn't just some wild guess. It's a quantitative forecast. For a strategist, this is pure gold. It helps you justify your investment, decide which countries to launch in first, and it shines a big, bright light on a real clinical need that's now clearly defined.
But here's the thing. It's not just about spitting out numbers. The AI also delivers these incredible strategic insights. For instance, if you're looking at a particularly aggressive form of colorectal cancer, it doesn't just give you the patient count. It tells you that a specific genetic mutation, KRAS, is what's driving the growth in that patient group. That one sentence, it basically hands you your R&D strategy, telling you to focus on biomarker-driven treatments. Now that is truly actionable intelligence.
And that ability, right there, to point you in the right direction, that leads us to what might be the ultimate benefit: using this technology to see into the future of a market with a whole new level of confidence.
See, planning in the pharmaceutical industry isn't about next quarter, it's about the next decade. A drug you start developing today might not even reach patients for 10 years. This is where these AI platforms are a total game changer. They let you model that entire patient landscape over that long haul. You can see what the patient pool looks like today. You can analyze how things are shifting by 2026, and, amazingly, you can project forecasts all the way out to 2034 to see where the need will be greatest when your drug is finally ready.
So, with that kind of long-term vision, you can do some really powerful stuff. You can forecast how many patients will actually get treated with the drug, not just how many have the disease. You can track population growth, zero in on the most promising patient segments, and pour your resources into where the unmet need is truly the highest.
So let's just boil this all down for a second. What's the fundamental shift here? What's the big deal? It's the move from a slow, manual, often frustrating process to one that delivers powerful insights almost instantly.
You know, the old way was kind of painful. It meant teams of analysts spending weeks, sometimes months, just combing through individual reports one by one. It was slow, it was siloed, and key insights were tracked in different documents. The new way, the AI-powered way, synthesizes information from hundreds of sources in seconds. It smashes those silos and frees up the brilliant human experts to focus on strategy, not just endless data collection.
At the end of the day, this technology has one job: to cut right through the complexity. It takes that massive, intimidating fog of data and turns it into something clear, dynamic, and reliable enough to build a multi-billion-dollar strategy on.
And all of this leaves us with a pretty mind-blowing final thought. We've actually reached a point where we can forecast the landscape of human disease with startling accuracy. So, if AI can help us solve that, what's the next monumental question in healthcare it's going to help us answer?